Good evening, students. How are you? Hope you are all doing well. I am Dr Smrutirekha and I welcome you all to Etuson, Education for Better Tomorrow. Etuson is a digital learning platform for Odia and English medium students. Then what are you waiting for? Please download the app and enroll yourself so that you won't miss any of the class. Have you watched my previous videos related to real numbers? You have not? Then it's not too late. Please go and watch my previous two videos related to real numbers where I have discussed about the concept of real number and just started Euclid division lemma. Correct? So let us go to today's topic. So what is it? It is Euclid's division algorithm. Now already you are acquainted with Euclid division. Correct? What is Euclid? Euclid is the name of the Greek mathematician. Correct? And division right from our childhood, that is from your third and fourth standard, you have already learned the concept of division. Correct? So here also that Euclid's divisions lemma we have studied, we have discussed in the previous class. So today we will discuss Euclid's division algorithm. So now in today's class we have used a new word algorithm instead of lemma. What is lemma? I had told you, right? Okay, you have forgotten. Okay, let me remind you. What is lemma? Lemma is a proven statement. What is algorithm then? An algorithm is a set of step-by-step procedure or a set of rules to follow for completing a specific task or solving a particular problem. So the definition sounds complicated, is it? So it will be clear with the following example. What is that example? You can see number of statements, right? So what are those statements? So if you can read it, so I think it is an algorithm for making cup of tea. Our morning doesn't start if we don't have cup of tea. But every day while preparing tea, we follow certain steps or procedure. Then only our cup of tea will be very nice and we will enjoy it and our morning will start very nicely. Correct? So what is the algorithm while making the cup of tea? So first what we do, we will fill the kettle with water. Correct? So first we'll fill the kettle with water. That is the first step. Then boil the water in the kettle. Then what you do? So you will put the tea bag in the cup. Correct or not? Then after that what you do? So because as in your kettle water is already boiled, you will pour the required amount of boiled water into the cup. Correct? So after adding the boiled water, then usually what you do? So depending on the requirement, you add the sugar. Correct na? Then after that you add milk into it. Then you will stir the tea. Then you can enjoy your cup of tea. So all these steps which is followed to prepare a nice cup of tea early in the morning, all these steps sequentially it is followed. Then only the result will be, our output will be a proper one. Your problem will be solved. What is your problem here? Your problem was initially to prepare one cup of tea. So you had found out a solution in which you have followed certain steps and finally your cup of tea was ready. Correct? So what is algorithm? So I think algorithm concept is now clear to you. What is algorithm? Algorithm is set of step-by-step procedure or a set of rules to follow for completing a specific task or solving a particular problem. Okay. So now how we are going to use this algorithm for Euclid's division algorithm. So how we are going to use this algorithm to find out the HCF of two numbers by this concept. Okay. So I think you know what is HCF. What is HCF? HCF is highest common factor. So as we have already discussed algorithm, certain steps has to be followed. So let us understand what are the steps to be followed to obtain HCF of two positive integers. So here let us consider those two positive integers as C and D, where C is greater than D. Okay. So the steps are, first what we will do, we will use the division lemma to find Q and R, where A is equal to BQ and BQ plus R. This we have already studied in Euclid division lemma. So in Euclid division lemma, always we express one integer in terms of in the form of dividend is equal to divisor into quotient plus remainder. Correct or not? Yeah. So first we are going to express in that form. Correct. Then we have to compare the remainder whether it is equal to 0 or it is not equal to 0. If it is equal to 0, then your problem is already solved. That means what is your answer now? Then your answer or the HCF will be equal to divisor, which is equal to B. If not, if the remainder is not equal to 0 in this step, then you have to follow the same step again and again. So in the next step, your divisor will be your new dividend, and again you have to uh, express that dividend in form of divisor into quotient plus remainder. Again you compare the remainder with 0. If it is 0, then there you got the solution. If not, you have to continue these steps unless and until you get remainder is equal to 0. So these steps I am just explaining you. Maybe you are not clear now. So it will be clear if we will solve one problem. So basically you know that while we can find out the HCF of two number by common method, that is factorization, and another method, that is division method. So what you do in factorization method, let us understand. I think it is this concept is not very new to you. So suppose we have to find out the HCF of two number, that is 30 and 15, by using factorization method. So in factorization method, what you will do? So you will find out the factors of 30. So what is factors of 30? So like this you will find out 2, then 15, then 3, then 5. Similarly, suppose you want to find out the factors of 15, you will get, so 15, then you take 3, then you take 5. So what you got? So 30 is equal to 2 into 3 into 5. Correct. And what about 15? 15 is equal to 3 into 5. So what are the common factors here? So here 3 into 5 is common both in 30 and 15. So what is HCF of 30 and 15? So HCF is equal to 15 over here. So HCF is equal to 15 for 30 and 15. Suppose I want to find out the HCF of 30 and 15 by division method. So how you are going to do it? So let us do. So 30 divided by 15. So 15 into 2, that becomes equal to 30. So what is your remainder here? So remainder is equal to 0. So if I will write 30 is equal to 15 into 2 plus 0. Correct. 30 is equal to 15 into 2 plus 0. So what is this form? How does it look like? It looks like how? Dividend is equal to divisor into quotient plus remainder. Correct. So here, because you got the remainder is equal to 0, so the divisor becomes the HCF. So HCF is equal to 15 here. So in both way, that is factorization and division method, you got HCF as equal to 15. Now what will happen if remainder is not equal to 0? So to solve that kind of problem, let us take one more example. Okay, so suppose I will take, instead of 30, I will take now 32 and 15. Okay, so 32, if I will write by factorization method, it will be, so 2, here 16, again 2, 8, 2, 4, 2 and 2. So finally your 32 is equal to 2 into 2 into 2 into 2 into 2. What about 15? Already we had calculated in the previous page, so I am not writing it in this form. Directly I am writing 3 into 5. So what is the HCF of 32 and 15? It is 1, right? So let us see how we will get this answer by division method. So I will take 32 as dividend divided by 15. So here you will get 2, 30, again 2. So because your remainder is 2 here, so you will take this 15 as a new dividend. Correct? So 2, 15. So the answer is 7. Then you will get 14 here. Again you will get 1 here. So the remainder is not yet equal to 0. So this 2 becomes your next dividend. So 2 here. So 1 into 2. So it becomes 2 here. Now the remainder becomes 0. Correct? So what is the HCF now? Now the last divisor which you got here, it becomes the HCF. So in this case, HCF is equal to 1. Is this not the same answer as that you have got in factorization method? Yes, it is correct. So in both the method you will get the answer. Then where you will use your factorization method and where you will use your division method or Euclid division algorithm. So basically when you have a very big number, it is very difficult to find out the factors of those big numbers. So in that case, it is preferable to go for Euclid's division algorithm to find out the HCF. Are you getting me? Okay. So let us solve some more problems. So we will solve this problem, that is use Euclid's algorithm to find the HCF of 4052 and 12,576. So let us try this problem. Okay, let us solve this problem. So as you can compare, so here your 12576 is greater than 4052. Correct or not? It is greater than 4052. So this you can consider as dividend. So 12,576 you will take it as dividend and 4052 you will take as initial divisor. So let us write down in form of Euclid lemma. So that is 12576 is equal to, so 4052 into 3 plus 420. Correct. So this 3 directly, if you can divide in the rough, you can divide and you will find out that this is the remainder. I hope you will do it. Okay. So now you just observe the remainder. Is it equal to 0? No, remainder is 420. So here our remainder is 420. So we have not got the HCF now. So what is the next step now? So again this 4052 becomes your new dividend. So what you will write? 4052 is equal to, and 420 becomes your new divisor. So 420 into 9, right, plus your remainder will be 272. Again you have not got remainder as 0. So you have to continue with the same steps again. So what will be your new divisor now? No, new dividend now. So new dividend will be 420. What about your new divisor? New divisor will be 272. So I'll write 272 here. So 272 into 1 plus, what's the answer? It is 420 minus 272, that is 148. Correct or not? Yeah, you can check it. I made two wrong, no, sometimes, because it is mathematics. So please check. If I am wrong, please comment and tell me, ma'am, you are wrong. Correct. Okay. So now I hope it is correct now. So now see, is the remainder 0? No, it is not 0. So what I will do now? Can you tell me? Anyone can tell? Yeah? No? Can you comment? Okay. So yes, correct. So what will be your new dividend? It is 272. So 272, and your new divisor is 148 into 1, and remainder is 124. Still you have not got remainder as 0. So you have to continue the same. So now your dividend becomes 148, that is equal to 124 into 1 plus 24. Correct. Now you take, again your remainder is not at 0. So your new dividend becomes 124. So 24 into 5 plus 4. Still you have not got remainder as 0. So let us try with new dividend, that is 24. So 4 into 6 plus 0. So finally you have got remainder is equal to 0. So what will be the HCF of the two number? So HCF is equal to 4 in this case. So HCF is equal to 4 in this case. So do you find any difficulty in this? See, this particular formula, that is dividend is equal to divisor into quotient plus remainder, it is a very well learned formula right from your third or fourth standard. So that you are using with a new name. I don't think it will be anything difficult for you. So please try more and more number of problems. So I will this two problems I am skipping, because we will go to that problem in the next class. So we will do this problem first, because we are discussing HCF. So in the while solving our exercise problem, that time we will go back to those two particular problem where we need to prove that how to express your even number, how to express your odd number. That problem we will discuss in the next class, because today we are discussing only about how to find out HCF using Euclid's algorithm. Correct. So what is this problem? Let us see. A sweet seller has 420 kaju burfis and 130 badam burfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tree. What is the number that can be placed in each stack for this purpose? So it's very easy. So to find out how many numbers of sweets should be placed, you have to find out the HCF of 420 and 130. So let us start by using your Euclid's algorithm. So first what I will do, because 420 is greater than 130, correct? So I will take 420 as dividend. So I'll write 420 is equal to 130 into 3, that is 390 plus 30, correct or not? So remainder is not equal to 0. So your new dividend will be 130, that is equal to, and new divisor is 30. So 30 into 4 is equal to 120 plus 10. Again the remainder is not equal to 0 here also. So if you want, you can just add remainder is not equal to 0. Here also remainder is not equal to 0. So you can just write down here. Again you take a new dividend, that is equal to 30. So 30 is equal to, new divisor is your 10 here. So 10 into 3 plus, now thank God, now your remainder is equal to 0. So here remainder is equal to 0. So you have got your HCF. So HCF is equal to 10. So what is the number that can be placed in each stack? So your required number is equal to 10. Correct. So this is how, by using your Euclid algorithm, you can find out HCF of two numbers. Hope this is clear for you. And the remaining problems which I had mentioned in the earlier slide, that definitely we will discuss while solving the problems from the exercise. Correct. So thank you for today. So please go and visit our website, and you will get all the videos in the YouTube. Follow us on Facebook, Instagram and Twitter, and don't forget to download the app. You know, there is a surprise for you. In few days we are coming live. You can solve many problems, and also you can ask your doubts directly. So teachers will be live, so you can just interact with with your teachers instantly. So what are you waiting for? Please enroll yourself. Okay, thank you, take care.